Alright, hi guys. Now we're going to one last video for this week. How to calculate significant figures. Basically, looking at problems that you're going to get in the problem sets and figure out how to work them out. This is what this slide is for. So without any further ado, let's keep going. Alright, first one, addition. How do you figure out the number of significant figures when we do an addition? So you're going to get these problems. They're going to be vertical. It's going to look like this. 0.03091 plus 0.2 plus 0.09. Do me a favor, put them in vertical. 0.03091. Yep. Okay. Then 0.2 and then 0.09. Try and keep them in the same order at least. Now this is what we want to do. I'm going to put dashed lines. And man, this is bad. And if you get something like this and it looks like, well, this looks kind of crappy, I'm going to try this again. I can erase, and you guys get to see me screw up again. And so 0.03091. And it's important to get everything under the right. So make sure the 10th place are all in the same place, the 100th place are all in the same place, and so on and so forth. 0.09. Now, you notice that there are gaps. We're missing these 3 places and 4 right here. So my last significant digit is this guy. This one right here. Sorry, I touched my pen. Stop that pen. Stop that. So if we add this up, this is going to be 0.91. 9 plus 3 is 12. And then make a 3 here. 0.32091. But, as I said, this is where my last significant digit is. So everything to the right of the 3 is insignificant. Since this is a 2, we keep the 3 the same. So my answer is 0.3. That's my answer, folks. One significant digit because of that one right there. Remember, the 0 holds place. So this is one significant figure, one sig fig. If I can know how to write properly. So that's how you do that. Again, on these additions, just line them all up, add, find the one where the number doesn't go to the right, least significant digit, and this is it. This is your last significant figure right here. These aren't because this number has number to the right of this, and so does this one. Even though this is a 0, it's still smaller than the 2. So guess what? The 2 is the limiting digit. I hope this makes sense. Now let's look at this one. 906.00 minus 0.11502. Again, let's do it. Write it on the screen. I do it on the screen, right? Rewrite it. And then 0.11502. 02. I'm subtracting these two numbers. This is my last significant digit because this ends at the 100th place and this ends farther back than that. So when I write this number, I'm going to end right there. And sometimes, folks, you can use your handy dandy calculator. It will give you a lot more digits than you want, but it will help you get the right answer. So my answer is, come on, pen, 905.88498. All right, here's my last digit. Don't need these. This is a 4, so I'll keep the 8. So my answer is 905.88, and that's my final answer. I have 5 significant figures. All right. both of these have 5 as well. So this is one of the few times when I do a subtraction, I actually get a big number. Sometimes, be careful. Sometimes you subtract two numbers, and because of significant digits, you end up with 0. That can happen. We'll try not to do it in this class, but it can happen. Just want to let you know. All right, this is subtraction. Let me know if you have any questions. Now, full multiplication. Now, you can do it like this, or you can do it vertically. I don't care. So you're going to multiply all these first. This one has 4 significant figures. This one has 4. This one has 4 as well. Because these two are significant. Why do I feel like I got a bad example here? But let's go for it. 0.07763. Just multiply them across. 0.05803 times 7.700, and I get a number. I'll multiply that across 0.0346749. Now I know it's not that many significant digits. All of these have 4, so I'm going to count 4. Not this one. 1, 2, 3, 4. This is my last digit. I don't need the 749. 7 is above 5, so this becomes a 9. So my answer is 0.03469. Why? Because since this is my last significant digit, the number next to it is 7, I round up. And this is how this works. We go by the number of significant digits each of these numbers have. Okay, last example. We're going to do a division. 3.000 divided by 0.070. This has 4 significant figures. This has 2. So when we take 3.000 divided by 0.070, I get my answer is 42.85714. Well, how many digits should I need? Well, I got 4 here, I have 2 here. So 2 dictates is the lowest number of significant figures. So 1, 2, I have to end at the 2. Don't need this, but number next to 2 is an 8, so this becomes 43, which is the right answer. If you have any questions over this, please let me know.